So this is section 2.2. I'm going to talk about histogram, frequency, polygons, and ogives. So there are three most commonly used graphs in research are the histogram, frequency, polygon, and cumulative frequency graphs or ogive. So constructing a histogram, frequency, polygon, and ogive, step 1, we draw or label the x and y axis. And step 2, on the x-axis, label the class boundaries of the frequency distribution or histogram, ogive. And then we're going to use a midpoint for the frequency polygon, okay? So we are using the class boundary for the histogram and ogive. And the frequency polygon, we are using the midpoint of the class. All right, histogram. The histogram is a graph that displays the data using the contiguous vertical bar, which is don't mix up with the bar graph. We're going to learn in the 2.3. Unless the frequency of the class is a 0. Various height of the represent the frequency of the classes. Okay, so example 1. Constructing a histogram to represent the data shown for the record high temperatures for each of the 50 states. So the boundaries, so I'm going to starting with the boundary are the 99.5 up to the 104.5 because boundaries are repeated, right? So first class, second class, like that, right? So 0 class, we got the 99.5 up to, isn't it? So we are using the lowercase, okay? And then 104 and then 109.5, 114.5, 119.5, 124.5, 129.5, and 134.5. And then also frequency, the highest numbers are 6, and the intervals I have is 1, 2, 3, 4, 5, 6. So I'm going to do the 18 divided by 6, which is a 3. So I'm going to make the each interval by 3. So 3, 6, 9, 12, 15, and 18. And then that fits everything in here, right? So between the 99.5 to 105 is a 2. So 2 is about here. And then 104 to 109.5 is 8. And then 109 to 114.5 is 18, which is the highest frequency. And the 114 to the 119 is 13, so about here. And then 119 to the 124 is a 7. Which it should be a little lower than that, okay? So I now want to make a little bit smaller, which is right here. And then the 1 for the 124 to 129.5. And then there's another one for the 135 too. Okay, so that's what we call the histogram. So histogram is connected each other as a bar. Frequency polygon. The frequency polygon is a graph that displays the data by using lines and connect the points that plotted for the frequencies at the midpoint of the classes. So we are using midpoint. So we are finding a midpoint first. So midpoint means you need to adding each class of the lower boundary to the upper boundary and then divide by 2. So you gotta do 99.5 plus 104.5 and divide by 2, and then I'll get 102. And then for the second midpoint is 104.5 plus 109.5 and divide by 2, I get 107. What happened? I have a line in here. I don't know why. Okay, all right, and then the next one is 112. 117, and then 122. What's going on here? I don't know why I have a line. And then this one give us a 127, and then 132. I don't know why. Okay, so and then I'll put the midpoint, so 102, 107, 112. Oh, which is, oh, sorry about that. I need to get to the lower, the lowest 0 class, the midpoint. What happened here? Okay, so which is a class width is subtracting from the 104.5 to 99.5, you get the actually the 5, isn't it? So 5 is the class width, which is if you subtract the 5 from the 105, you're gonna get 97. So I'm gonna start with the 97, 102, 107, 112, 117, 122, 127, 132, and then we're gonna closing up to the at the x-intercept, so adding 5, so 137. So starting from the 97 is a 0 frequency, and then 102 is a 2, which is this is the same thing, 3, 6, 9. 3, 6, 9, and then 12, 15, and 18. So 102 is going to be a 2. Hold on a second. I don't know why I'm getting those here. So 2. 107 is 8. Oh, my goodness. Eight. 112 is 18. And then I think I need to move a little bit up here. And 117 is 13. And then 122 is 7. And 127 is 1. And then 1. Okay, so if you connect them, this is what we call the polygons. And then 137, of course, is 0. Okay, so it goes like that. And then ogive we are using for the cumulative frequencies. Alright, so what we're going to do is we're going to find the cumulative frequency, which means whatever you had it earlier, and then we're going to keep that in. Okay, so last at 99.5, which is you have to look at the up to 99.5 up to here, which is nothing, right? So this is going to be the 0, and then up to the 104.9, which is a 2, and then up to 109.5, which is 10, isn't it? So keep adding the next number, and then the 114.5 right here, right? So up to here, so you're adding the 28. And then up to 119.5 right here. So adding 13 from the 28, 33. And then 124 up to, so right here. So adding 7, which is a 40. And then you're adding the 141. Did I miss something? And then 40. Hold on. What did I mess up? Okay, sorry about that. So 33. Did I skip something? Oh, not 33. Okay, so 28. And adding 13 is going to be the, sorry about that, this mess up. Not 33. And then makes it 41, adding 7, 48, adding 1, 49, adding 1, 50, okay. Yeah, that's all. So ogive, we are using the boundaries too. So boundary we found is 99.5, 104.5, 109.5, 114.5, 119.5, 124.5, 129.5, 134.5. And then other one, the 50 is the highest number, so I want to say each one is a, I want to get to the 2, 3, 4, 5, 6, 7. Oh yeah, 10. So I'm going to say 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. So starting from the 0, 0. And then 104.5 is 2. And 109 is 10. And 114.5 is 28. And 119 is a 41. 124, 48. And then 49 and 50, isn't it? So this is observe is always increasing. Connect this together. Alrighty. Now we're going to talk about the relative frequencies. So in order to get a relative frequencies, the distribution can be converted to distribution using the proportion instead of the raw data as a frequency. So we are using we divide by total number. So the construct the histogram frequency polygon observe using the relative frequencies for the distribution shown. This is a graph, a group frequency distribution using the ages at the time of this writing of the governors of the 50 states of the United States. So find the midpoint for the frequency polygon. So in order to find the midpoint, we have to add in these two numbers together and divide by 2, which is 45. I got 50 and 55, 60, 65, 70, and 75. And then relative, so and then when you're adding the frequency total, which is 50 states, right? And then you are actually divided by that. So 45 divided by 4 divided by 50, which is 0.08. So this is coming from the 4 divided by 50, okay? And same thing, 0.08. And the 11 divided by 50 is 0.22. And then 14 divided by 50 is 0.28. And 9 divided by 50 is 0.18. And 5 divided by 50 is a 0.10 and 0.06, okay? So, and then we're ready to find out the histogram and frequency polygons too, okay? So histogram, we are using the boundaries, okay? So we have to get to the class width. So which is a 5, isn't it? Okay, so subtract 5 from the 47.5 is a 42.5, isn't it? And then adding the, yeah, up to the 7, yeah, that's fine. So starting from the 42.5 and 47.5. 52.5, 57.5, 62.5, 67.5, 52.5, and 72.5, and 77.5. And then the highest number you can get is a 14, but we have to use the relative frequency. So highest number we can get 0.28. So each one I want to say 0.05, 0.10, 0.15, 0.20, 0.25, 0.30, okay? So 4.25 is actually the 4.25 between the 47.5 is going to be 0.08. So about here. And another 0.08. And then 0.22. And then next one is 0.28, close to 30. And then the 0.65, which is 0.18. Oh, excuse me. So 0.18 here. And 0.10. And then we got 0.06. Okay. All right, that's a histogram. So, and the frequency polygons, we're using the midpoint, and then the midpoint below the 45 is at 40, right? So starting from the 40, 45, 50, 55, 60, 65, 70, 75, and then we go up to 80, be close, okay? And then we are using the frequency too, so which is, I want to say 0.05. 0.10, 0.15, 0.20, 25, 0.30. So 40 is a 0. And then the 50 is a 4. Oh no, 50 is a 0.0, 0.08 and 0.08. And 55, 0.22. 60, 0.28. and 0.18 next one, and 0.10, and 0.06, and then 0, isn't it? So we got this frequency polygon graph. All right, here we go. All right, now the ogive. Okay, now we need to get to the cumulative frequency first. Okay, so cumulative frequency was 4. And oh yeah, we have to get to the up to here, right? So sorry about that. So we're starting from the 0 and 4 plus 4, 8, and plus 11, 19, plus 14, 33, plus 9, 42, and plus 5, 47, and plus 3 is a 50, okay? And then cumulative is divided by 50, isn't it? So you divide by 50, so 0 divided by 0, 4 divided by 50 is 0.08, 8 divided by 50 is 0.16, 19 divided by 50 is 0.38, and 33 divided by 50 is 0.66, 0.84, and 0.94, and then 1.00, okay? And then the ogive, we are using the boundaries, okay? So we gotta do as x as starting from the 42.5, 47.5, and then 52.5, 57.5, 62.5, 67.5, 72.5, 77.5, and then you go up to 1. So I want to say 0 0.1, 0 0.20, 0 0.30, 40, 50, 60, 70, 80, 90, and 1.00. So starting from the 0, 4.75 is 0 0.08. Oh, sorry, here, what am I doing? 5.2 is 0 0.16. And then 0 0.38, 0 0.66, 0 0.84, and 0 0.94, and 10. Okay. So that's ogive. Okay. All right. Now, using the histogram to describe the shape of the distributions. Okay. So although distributions not often perfectly shaped, and then identify an overall pattern. Okay. So bell shape is about the U shapes. So when you see U shape, we call the bell shape. Uniform means the y value come out the same. Okay. Whatever value that come out the same. And then J shape means increasing to the decrease from the increasing. Okay. Increasing. And reverse J shape means about decreases all the way. Like skewed means which side is skewed, so flat. So this is important. So right skewed and the left skewed, okay? And then the bimodal means what? There's a two highest points, okay? So there are two parts of that. And the U shape, yeah, this is the U shape. So the U shape is the opposite of the bell shape, okay? All right, so we'll see those. Okay, thank you for listening.